Hello guys, so in this video I want to do problem 8.2.3 from section 2 when we need to find the volume of some curve when we're going to rotate the curve around x-axis. So in this case my curve is 2x plus 1 and my restriction is y equal to 0, x equal to 0 and x is equal to 4. So first let's sketch y is equal to 0 and actually let's try to visualize our restrictions. And y equal to 0 is just x-axis, and we know that x is equal to 0 is y-axis, and x is equal to 4. I'm going to just draw a line parallel to the y-axis that goes through the point x is equal to 4. And my region is going to be between these two parallel lines. Then I'm going to find f of 0, and f of 0 is equal to 1, and f of 4 is going to be equal to 9. And if I want to sketch a line, what do I need to do? I just need to sketch these 2 points and sketch a straight line between those 2 points. Okay, and how is my actual surface going to look like? I'm going to take that line, reflect along x-axis, connect by those 3 circles, and then you can see what I want to do. I want actually to find the volume of the that 3-dimensional shape. So that shape looks something like a vase, I don't know. And again, that shape is given, I'm taking that line segment and I'm just rotating that line segment around x-axis, and I want to compute the volume of everything between those 2 opposite line segments. So to actually compute the volume, what I need to do, I need to apply the formula, which is like pi times the integral between my bounds, and my bounds 0 and 4, of my function squared. And since my function is 2x plus 1, then I'm going to obtain the following integral. But here I'm going to do a small trick, and I know that the answer is going to be 2x plus 1 to the power of 3 over 3 times 1/2. And the way how to check this, remember that integration and differentiation are opposite operation. So if I'm going to take my answer and differentiate, and if I'm going to get my original function back, in this case I did get my original function back, that means that I actually get the correct answer. And then I'm going to plug in my boundary points from 0 to 4, and if I'm going to plug in my boundary points into my answer, then you can, after doing simple computation, see that final answer is 364 pi over 3. So let's do the same for problem 8.2.7, where in this case we have our function square root of x, and our bounds y equal to 0, x is equal to 0, and x is equal to 8. So again, I'm going to just sketch my bounds, and you can see that my region is going to be bounded between these 2 parallel lines. And to sketch my square root function, I just need to find that when x is equal to 0, my function is equal to 0, and x is equal to 8, my function is going to be 2 square root of 2. So again, I'm going to sketch 2 points, and I don't need to worry about where exactly is going to be my second point, but my function is going to look something like this. And then if I'm going to rotate my function around x-axis, I'm going to obtain the following 3-dimensional shape. And my goal is to find the volume of that shape. So again, I just need to relate the integral pi times from 0 to 8 of f squared dx, where f is my square root of x. And then you can see after simple calculations, what I'm going to obtain. I'm going to obtain the answer 32 pi. Finally, let's do an interesting extra problem where we need to find the volume between 2 curves. So let's take a curve f is equal to x and g is equal to x squared. So what do we need to do? First, let's try to sketch our section. And we know that function f is equal to x is going to be just straight lines that goes through the origin and makes 45-degree angle with x-axis. But what about g is equal to x squared? G is equal to x squared is going to be parabola. And to find that parabola, we just need to know 2 points. And we have those 2 points, 0, 0, and 1, 1. And then we can see that we have the following section. So our region. But what about bounds? Because for the previous problems, we knew our bounds. Then we can see to find our bounds, we have a first point and second point. And for that first and second point, what do we need to do? We need to find the x component. So how to find our x component? If you're going to take a look at this point, then you can see that function f and function g equal to each other. So what does it mean? It means I just need to set them equal to each other. Then we're going to have that x is equal to x cubed, and I need to solve that equation. But if I'm going to factor my x, I will obtain that one solution is x is equal to 0, and another solution is x is equal to plus minus 1. And since our region is on the right hand side of y-axis, that's why we know our bounds, which are x x is equal to 0 and x is equal to 1. So for our next step, like how do we actually find the volume? So what is the approach? So first, let's remind ourselves what is our origin. So we can see that our origin, if I'm going to sketch, is going to be function y is equal to x and y is equal to x squared, and I'm going to rotate it around the x-axis. So I'm going to obtain like this three-dimensional shape. It's pretty difficult to draw, but you can imagine how it looks like. But if you will think careful about that shape, you can, like, what we can actually do, we can represent the shape as a difference of two different shapes. And you need to observe the following. If you're going to just take a function y is equal to x, then, and we're going to sketch it and rotate that line segment around x-axis, you're going to obtain like this three-dimensional shape. And if you're going to take parabola and rotate around the x-axis, we're going to obtain the following three-dimensional shape. And original shape that we want to find is going to be the difference of v1 and v2, because I want to find the volume between those two curves. Or in other words, like the formula is going to be the following. For the first volume, from the previous problems, we know that the volume is equal to pi times the integral from 0 to 1 of f squared dx minus the integral from 0 to 1 g squared dx. And I miss like pi, but you can think about it, I just factor my pi. So if I'm going to bring those two functions under the same integral, I'm going to obtain that pi times integral from 0 to 1 of f squared minus g squared. And then if I'm going to just plug in my f and g, then I will obtain that my integral is going to be equal to pi times x cubed over 3 minus x to the 5 over 5 between 0 and 1. And after I'm going to plug in my boundary points, I will obtain that my final answer is going to be equal to 2 pi over 15. Okay guys, thank you for watching. Let me know if you have any questions, and have a nice day. Bye.